Welcome back to Hacker Talk, the podcast by hackers for hackers. This is the second episode with Ben Kurtz. My name is Philip and I will be your host for today's show. In case you missed part 1, we covered Ben's background, getting into hacking, Golang Malware, calling functions in Windows without being detected by antivirus, by calling libraries that are already loaded instead of re-importing all of those libraries like a normal program would. Here comes part 2. Enjoy.
A friend of mine in Australia, CISO, made a library which also uses the debug, the library, but he actually implemented Hellsgate in Go. And Hellsgate is an EDR evasion technique on Windows, which is a way of making what they call direct system calls, which is not a concept in any other operating system. This is just a Windows only thing. And it is because there are you don't directly make system calls in Windows. Normally you call system calls in Windows through stub functions that are in NTDLL. And those stub functions in NTDLL have a particular layout. And inside that layout, there is a number, and that number is the system call number, right? And that system call number.
It's not like syscalls in Linux with libc.
No. Oh, God, no.
It's another word.
Syscalls in Windows are regular library calls.
Okay.
Because the kernel is exposed as libraries in Windows.
Mm-hmm.
No, if you're not familiar with the Windows kernel, it is crazy town. It is very, very different than the Linux kernel, and that's a whole other conversation.
Yeah.
But so there's this is just how things are on the ground in Windows, right? Like, so normally what you don't make a direct system call. Normally your library is compiled against the NTDLL library. And when your code is calling system calls, they're actually calling exported library functions in NTDLL, and then they're getting rerouted to the system call, right?
Mm.
But they're being rerouted through these templated function. Like there's these template functions in NTDLL for each kernel system call that is nothing but the same template over and over, and each one of them, and it has the number of the system call that stub is for in it, and that the number of the system call is in a known location. Okay, and that's key. So basically, the Hellsgate method for avoiding EDR, and why this avoids EDR, is a common technique for detecting malware that EDR uses is to hook the functions in NTDLL. So they will actually alter NTDLL in memory. They will replace the system call stubs with functions that call back into their own stuff and do some monitoring, and then eventually call out to the system call, right? So they hook these system call stubs to route back into their own thing and trigger detections, right? So you want to avoid these hooks. The Hellsgate method, basically what it does is it finds NTDLL in memory somehow, or it loads it again from disk. If it's already been hooked, you load it from disk and parse it, and you parse NTDLL. You look for the functions that you want. You pull out the magic number, for the system call that you want, and then you rebuild the stub function in memory, and then you use the stub function that you built in memory as the kind of like stack setup to call directly into the kernel. You make a direct system call. All right. And that avoids NTDLL if NTDLL has been hooked by an EDR. And that actually works out of the box on a lot of EDRs. So there is a repo, CISO's Banana Phone. Banana Phone makes this as easy to use from Go code as the regular syscall interface. He made an entirely a syscall compatible tool called Make Direct When Syscall that can convert it works the same way as the regular Make Syscall. So there's this Make Syscall utility that comes with Syscall and Golang, where you give it a file that has the header, the Windows prototype, the Windows function prototype of the function that you want to call into, right? Mm-hmm. You paste that header into a comment in a file, and then you run this utility on it, and it generates the Go stub code for you. and then you can just call it from your code as if it was a regular function. Okay, that's how syscall works normally with the utility called makewin syscall. So Csto, as part of BananaPhone, made a complementary utility called makeDirectWin syscall, which works exactly the same way, but it BananaPhones your syscalls. It hellsgates them. It will automatically make them bypass NTDLL and go directly to the kernel on Windows. It will automatically bypass a lot of EDRs, at least that part of their detection. And so there's we've just been slapping BananaPhone on everything. So you'll see BananaPhone get used in Go Mimikatz, at least some versions. I use it on everything basically in Windows. There's no particular reason not to. And yeah, I don't know. That's just that's one of the more useful Golang malware repos for sure.
Nice. So if someone that's been doing a bit of Go wants to get into writing implants and writing malware, where do they start? Where do you think is a good way to start writing? What kind of libraries should they look into?
Right off the bat, I would look at Sliver.
Sliver.
Yeah, I would. It's from Bishop Fox, which is a red team style consulting company. They're pretty high end. They have some very, very, very sharp people. I'm sure they also do non-red team consulting too, but the Sliver C2 implant framework was developed by their red team folks for use, by their red team on actual engagements. It has been continuously worked on for a really long time. It has some really interesting and unique features, and it will get, if you look at the source code, I would recommend looking at I'm not saying use Sliver necessarily, but I would recommend installing it, playing with it, seeing kind of how it works, seeing what the different features are, and maybe just looking at the source code for those different features to see how they work, to see what libraries they use under the hood. That's why we published all of this as open source. This is not about writing actual malware and actually hacking into real targets. This comes from a place where we've been running out of ways of saying this because the culture at large doesn't seem to want to understand how dependent they are on computers and how garbage computers actually are as implemented, right? When you watch TV, they have hacker characters all the time, but they're doing things that aren't even physically possible a lot of the times. And they have to be, really, really smart to do this. Oh, they're so smart, they can hack into things. Well, and it's that attitude is entirely wrong. You don't have to be smart at all to hack into things. You just have to be stupid really fast, basically. That's one way of going about it. There's a lot, because the fact of the matter is, it's a lot easier to screw something up than it is to do something right. It's almost impossible to do something right. And people, there's a lot of people, and every year that passes, there are more people working in computers writing code that are less educated, which is, that's great. It's great that people are, getting better paying jobs after taking a 12-week Python programming course.
Mm-hmm.
That is a great thing for a lot of people. But what it does mean is that there is exponentially more code being written by less trained people every year that passes.
So more bugs and more easy ways to get in. Yeah. Not even just more bugs. The rate at which there are more bugs is astonishing. And the rate at which we find bugs is astonishingly small. So have you heard of CVEs, the common vulnerability? Yeah, of course. Common vulnerability.
But what is the E? It's common vulnerability index.
I don't know. Enumeration, no?
Enumeration, something like that.
Enumeration, yeah.
Yeah.
Common vulnerability enumeration, yeah.
But CVEs are kind of a scam, right? Because they only actually publish a small percentage of the bugs that get reported to them every year.
Yeah.
And that's because they can only physically look at a small percentage of the bugs that get reported to them every year. So people think, oh, there were like a few thousand, CVEs in whatever year. That's how many bugs there were. No, that's like a small percentage of the number of bugs that were known. The number of bugs that there were is going to be like orders of magnitude higher than the number of bugs that were known, right?
Yeah.
So like the number of bugs that there are is, I'm going to say it's astonishingly close to infinite. Like basically I could find bugs for money forever and probably still find bugs. Like it might take me longer and longer as I go. There might be a diminishing returns type situation, but you're never going to entirely run out, right? And this is also why I prefer to be an attacker, because at least I can win. And I think I'm just not. I don't have the mental fortitude to struggle day after day on
chasing the unicorn and just making it better and better. And
where I just know I can't win, right? Or it's just I'm just counting the seconds until I lose, right? I think that would be difficult for me personally. I'm frail like that. But
is there any like I assume you do like a lot of code audits and stuff like that, or review source code for pen testing? Is there any like common patterns that you continuously see?
Yes.
Yeah.
That's why it gets easy. It gets so easy to find bugs in code because people are more similar to each other than they are different, right? And that means that when, especially less trained people, right? So like if I look at the code of like 10 people that came out of a 12-week course, they're going to make the same kinds of errors. You know why they're going to make the same kinds of errors? Because they didn't talk about cross-site scripting in their 12-week course.
Mm-hmm.
They didn't talk about SQL injection in their 12-week course, or they talked about it really briefly, and maybe it wasn't even described correctly, or it wasn't described completely, or who knows what, right? Like, but honestly, 12 weeks is like, if you learn programming in 12 weeks, that's pretty impressive. That's going to be like fundamental concepts. It's not going to be all the nuances of all the things that you can possibly do wrong, because there are, as I said, infinite things that you can do wrong, and it will take you a lifetime to discover what all of those are. The one thing that's kind of made things better, made things worse, is the rise of JavaScript, right? So like the vast majority of programmers now work only in JavaScript. There's like Node, there's like React, there's all the front end stuff. But what's come along with that is that a lot of the JavaScript frameworks people are writing in make it a lot more difficult to make some of the traditional errors. So you do see classes of bugs kind of going away, or becoming less useful. For example, cross-site scripting used to be a much bigger deal. It still would be a big deal now in a lot of circumstances, but just because of underlying technologies at use, like content types, maybe you're just not even going to hit it because there's no way the developer can screw it up. SQL injection, there's always the possibility for a human to introduce SQL injection through screwing things up.
Yeah.
Because the SQL layer just doesn't know that you concatenated a string. So that's just always going to be a bug. I've had a lot of luck in modern times with XXE, XML External Entity Inclusion. What does the E stand for? External Entity. Oh man, I always want to put an I where an E is. I don't know what it is. Something's wrong with me. But the XXEs, basically where you put your injection string in an XML and you try to get it to include a remote DTD, or schema document. And you can use that to exfiltrate data. You can use that to scan internal networks from the outside. You can use that to do you can use that to spoof emails to an internal SMTP server. You can use that to do so. You can use that to do some weird stuff if you get into XXEs. But it's pretty cool because it's a bug that is everywhere still. It's pretty easy to find. It's fun to play with. It can, in some circumstances, it can lead to code execution at some weird, and obviously like shell injection is still, everywhere. The log4j thing.
Yeah.
Log file injection is now like in remote code execution, and all you have to do is set your user agent to an attack string and get about business, and maybe you'll just get code execution somewhere. You don't know. That's where we live now. It's gone like we thought when I got into working in security like years and years ago. I thought, hey, we'll just enumerate all the types of bugs. We'll tell the people about all the types of bugs. Then they won't write any code with the bugs anymore. They'll fix all the bugs, and then the industry will go away. right? That's what I thought was going to happen at the time. But what happened instead, when I started working in computers, everyone who programmed had a degree in computer science. What happened instead, though, is that the demand for programmers grew exponentially and the supply actually dropped off for like a 15-year period. After about 2003 in the United States, the number of computer science graduates actually decreased. And it didn't get back up to the same level until like 2017 or something. So, what was business supposed to do? They needed websites constantly, ever expanding websites for every business.
Yep.
And so they just started hiring people out of 12-week programs, and they started introducing the same old bugs way faster than ever. And that it became clear to me that the whole like professional hacker industry, the security engineer industry, is basically morphing into how do we funnel developers through some chute where we have choke points where we can, prevent them from making the most egregious errors with the least amount of effort on our part, right? So we can touch the most teams on their way to production. As efficiently as possible, right?
But how do we do that? Do we create secure operating systems that give them a safe playing field, or do we create stable programming libraries that they can't fuck up? I mean, it's
that's definitely part of it. A lot of it is process too.
Mm-hmm.
One company might hire like 150 developers or something, and then they'll hire like 1 or 2 security engineers. And they'll just use the security engineers to do the final check on this code that's written by the inexperienced developers before it gets shipped, right? And that's kind of become the model. So what happened is, when I started out as a security consultant, I thought, hey, we're just going to tell all these people about these problems, and then they'll stop doing it, and then I'll move on to do something else with my life, right?
Yeah.
But what it turned into is they were like, hey, we've got these guys that can just look through this code and be like, there's a problem, there's a problem, there's a problem, there's a problem. I'm done, right? And that let them, instead of having someone like me as a programmer, they have someone like me overseeing the output of many programmers. And that lets them hire less experienced programmers that are more likely to make errors, but it's fine because now we've set up a process where if they're about to do anything that could break anything bad or make a big vulnerability, we do a little bit of triage. We're like, hey, are you touching anything dangerous? No, do whatever. We don't care. Are you going to touch something dangerous? Okay, well, let me have a look at that real quick. And I'm just going to have a quick look at that for what we think are the most critical issues for whatever it is you're doing, right? So it's become a lot more about optimizing the utilization of the more skilled resources that you have, because you can't hire them.
Mm-hmm.
Like the demand for security engineers far outstrips the supply. And it's in a way it's nice, I don't worry about job security. I get sort of my choice of things I want to work on or whatever. On the flip side of it, I do worry about my species. I think we're probably all going to die in a fire at some point.
And we're all gonna turn extinct.
And it's
maybe.
Oh, well, I mean, sure. But I mean, like, literally, like, I thought Terminator was a bit of a joke the first time I saw it. And now, and like, as time passes, I'm like, that could totally happen.
Yeah.
Yeah. But it might not even require like this magical thing, like artificial intelligence to just magically develop. It could be something as simple as like Elon Musk moves to Mars and then just like thinks it would be funny to, destroy the Earth by remote control. Right. Did you ever see that video of him suggesting we nuke both poles on Mars?
No,
his eyes lit up. That's all I'm saying. Right. Like, you don't know, like, I mean, I'm not saying he would do that, but you could see how that could happen in like 50 years out. That's a foreseeable future, and that's a wacky one, right? Like I'm not even like railing off any of the numerous more likely ways things could go terribly wrong, but I'm just talking about like all of us, almost all of us humans. We don't know where our food comes from. Like we're entirely reliant on the system we live in for survival. If you're a diabetic or you wear eyeglasses or you have to take some kind of medication to survive, it's like you can't necessarily make that yourself from stuff you find outside. It goes a little further than that. It's like most people can't even produce enough food to keep themselves alive continuously. Most people get food from the store and it gets delivered to the store from some massive supply chain they don't really understand. And we've become so insanely specialized that all we have to do is know about our one little narrow segment of things, and they give us our biosurvival tickets and we don't have to think about anything else, right? So the problem comes from the fact that we've built these incredibly complex systems out of duct tape and baling wire. And they were all built by people who didn't really give a crap about what they did at their day job because their life was really about something else, or their manager was a jerk, and their manager wasn't technical anyway and didn't even know what the hell they were writing and had no idea if the code was good or bad. And then all this stuff, like that didn't get tested right. And it got, it got shipped and it seemed to work fine. So they just left it. Right. And that is the story of every power plant, water processing, system, chemical plant, like nuclear power plant. They do have like stricter testing regimes for some things, but I've seen those testing regimes and they're not great, right? They're not complete. Like the coverage isn't always great. Like they're usually very narrow. Like there's a certain way that they were thinking about the problem at the time they wrote those regulations that hasn't been updated and is very difficult to update. There's always some reason, and then even if the rules are right, if the regulations are right, the odds that the implementation is right, the odds that the thing was actually set up in a secure way is like probably not, like things need to be maintained. So whoever it is who needs to maintain the thing, whatever it is, the chemical plant, whatever, odds are somebody poked a hole so that the people who need to maintain it can get in, and I don't know. There's a bunch of stuff like that. So there was this whole round of like, when people got really into SCADA exploitation, and it was SCADA. Like, oh, hey, we'll go on Shodan, and we found like there's 3,000,
nuclear
water facilities around the world that have their SCADA HMIs, their human machine interfaces just available on the internet with no authentication. So you could just connect to these things and like basically make them explode by like twiddling with the water pressure in some pipe until it like, maybe you make a water hammer out of it. You pulse it until some pipe, and some elbow gives out somewhere, right? Like that's a theoretically possible thing to do.
Yeah, and everyone in the entire world has access to it because it's open on the internet. Yeah.
And so on the one hand, you're thinking, well, no one ever connected to it before, but it was open this whole time. Maybe my whole job is pointless. We shouldn't even have passwords because like, what are the odds someone's actually going to exploit something anyway? It's like you leave it on the internet with no password for years and it's fine, right? But like, there's that moment when everybody knows it's a thing, then everybody just goes to Shodan, finds all of them, and they all get popped in a weekend. Like that log for J thing. That log for J thing blew up fast. That was like within a day. They had 2 other patches out within a day because, the people who were scanning for bugs, they kept finding more bugs. And you could literally see what they were scanning for just by looking at your own logs.
Yeah.
But if you looked at the other logs, you know they're, that they found some other bugs too in the log4j stuff that haven't even necessarily been patched yet. And some of those other scheme handlers, there's some other weird, like just phone home and run my code functionality. Java's a freaking nightmare. Like just preventing Java from remote code execution is almost impossible.
Yeah. I'm kind of hoping with all these new programming languages that they will just jump off and start replacing Java. I know it will take a really long time because there's so many legacy systems that are written in Java and so many employers hiring Java people. And
I also recommend Go for microservices. It's not just good for malware. It's great for microservices. It statically compiles to a native binary, which means that there are no external dependencies to your binary. You don't need to worry about the DLL hell or including libraries. Everything that the program needs is in the one binary. And there's no, it's a native binary. So it does not run a VM like Java. For companies that are entirely in the cloud, you actually can generate a report of where your cloud costs are going in terms of CPU cycles. And I would recommend you run one of those and look at how much money you're spending just on Java virtual machine overhead, because it's shocking.
it is insane. It's insane.
Yeah.
That's
So,
the JVM is eating up
there are-
way too much resources.
There are a lot of companies that are switching to Golang for microservices, especially because if you're already in a microservice environment, it doesn't matter that all your services are built with the same language. So you can kind of just move them from Java to Go one at a time. And the other one you mentioned is Python to Go. Python should never be a web service. It's it's a slow interpreter. It's a great language for data processing. It's great as a foreign function interface to native code. But guess what? You should never be doing on the web. You should never be taking web requests and funneling them into native code. You should just never, ever do that. That's the thing they did in the old days. You should be like funneling it into a browser sandbox or something. Like you should not be going to the web and putting that into a native DLL. I don't know. There's a lot of potential issues with that. It has support for like a lot of kind of the current generation of orchestration software is written in Go, like Docker's in Go, Terraform's in Go.
Docker is written in Go. I didn't know that.
Oh yeah. Kubernetes. Kubernetes, Terraform, and Docker are all in Go. There's a lot. Also, WireGuard is in Go.
Oh yeah, the VPN. That's getting so popular.
That's
VPN. Yeah.
Oh my God, that's so cool. So it's about time someone made VPNs like idiot proof. Like you can it's a distributed VPN. You can set it up in 10 minutes. You can put all your friends on a VPN, even go for all the links, setup's wicked easy. Yeah. There's just a lot of like regular current generation or orchestration stuff in Go. And I don't just write Go malware. I also, I do like Go services over Kubernetes and stuff for some of my hobby projects. And I end up pen testing those environments also more and more. Companies are deploying stuff that way. So I've done a fair number of like data center pen tests or cloud environment pen tests, which is pretty entertaining. So I am encountering Go more and more when I'm actually doing a pen test. So looking at it from that point of view, it is a lot easier for people to write secure code in Go by accident, than it is in Java or in most other languages. In Python too, there's a lot of really dangerous mistakes people can make. Really common. Yep. Oh, you asked about common patterns. Let me see how many I can rail off.
Yeah,
well, we'll do it by language, right?
Okay.
So in Java. Looking at the code, one pattern that I see there's a few patterns that I see super commonly. Okay. One, and these have existed forever. One is in the file constructor. In the file constructor, it takes two arguments. One is the base path and one is the file name. Most people assume that Java will canonicalize the path and make sure that it does not have directory traversals in it, but it does not do that. It simply appends one argument to the other with a string concatenation and then proceeds. So the new file constructor allows directory traversal. Anytime someone does new file in Java and they're not calling get canonicalized path separately, there is a directory traversal. I found that bug in almost every Java source I've ever looked at. I don't know. It's so freaking common because you just, I want to make a new file. Oh, we'll pass in the name of the file from a web request. Well, you failed. Like just that easy. Right. Okay. The next example is pretty simple. This has some crossover with the log4j bug. Any use of LDAP in Java goes through the class DirContext, which is which came up in the log4j thing also, although in a slightly different way. DirContext, most people assume that it does some kind of sanitization of special characters. It does not. You can straight up always do an LDAP injection through DirContext. If they are not explicitly sanitizing incoming user-supplied strings for LDAP special characters.
Is there no built-in sanitization or filtering? Nothing.
How could they do it? There's no way they could do it. This isn't a bug they can fix. At the layer of abstraction they're at, they don't know which part of the string is valid. Like they don't know what they can't filter it once you've already constructed the request. It's almost the same problem as SQL injection, right? You in order to solve SQL injection, you have to do a parameterized query.
Yes.
In order to solve this for LDAP, they would have to make a version of DirContext that had parameterized queries. I don't know if they ever did that. If they did, I've never seen anyone use it. Right? Like I don't think it exists. I can't be bothered to go look it up, but I believe that it does. There is no parameterized query thing for LDAP, or anyway, if they're when they don't use it, which is traditional. You can always do LDAP injection, which is like a lot of people think, who cares? But if I know the layout of your LDAP tables, sometimes that's an authentication bypass. Sometimes I can just log in. If your thing is open source and I can go look at how the LDAP layout works, like what the name of the things are in LDAP, I may just be able to straight log into your thing without knowing anyone's name or password. That's a surprisingly common bug in Java. Okay, both of those are old-timey bugs. Let's talk about something a little bit newer. A lot of people are using the Apache Foundation projects to do large-scale Java cloud stuff. A lot of those projects say that they're secure and have heinous problems or have not really been reviewed. Okay, so I have found a bunch of bugs over the past few years in Apache Foundation projects. I have reported some of them. I have reported all of them, I should say. I've tried to report all of them. Is probably more accurate. Not all of them were accepted, but a lot of them have been fixed. But the people assume that those projects are bug free, and sometimes they are just terrible security nightmares. So one example is Zookeeper. A lot of people use Apache Zookeeper for cluster management and kind of like load balancing, kind of etcd type stuff.
Okay.
But it is a security nightmare. There are 3 different settings in their ACL system. One allows universal read write, and the other 2 are labeled unsafe in all caps. So that's skimming the surface. That's skimming the surface of what's wrong with Zookeeper. But what commonly happens when people install Zookeeper or several other of the Apache Foundation projects, including Kafka, what commonly happens is that those installers would automatically turn on JMX, and by default, JMX does not require a password. JMX is the Java manageability extension, and it is one of the many ports that Java will open up that will just run code from the network. A lot of cloud things will install Zookeeper. Zookeeper automatically turns on JMX. JMX by default has no password. All they did was install Zookeeper. Now there's a port listening on their instance that I can connect to and execute whatever code I want with no password.
Nice.
Just that simple. There's a lot of other similar problems with Java, including the Java debugging port. If anyone ever uses Eclipse to remotely debug to an instance in production, they will enable the Eclipse debugger. That is another Java port, or the Java wire debug protocol. And that is another type of Java port that will just listen with no password and run whatever code you send it. And that's not even all. There's also RMI servers, which you commonly see with like JBoss, like Java application servers commonly fire up a whole bunch of RMI listeners, and sometimes you can just connect to those and run whatever code you want. There's also log file injection that can lead to remote code execution in Java. There's all kinds of stuff. Like other than log4j, there's other ways of doing it that are commonly supported in Java beans and bean servers. There's also the deserialization bugs, which were really common in Java, and there was a whole generation of those. And without even getting into the deserialization bugs, which can get a little bit tricky. Some of them still work, but those are ones that rely on side effects of constructors of things. So it's like you might not even necessarily get direct code execution, but there are still gadgets that you can get, functional gadgets that you can get from the constructors of certain classes or beans that you can find on targets sometimes. But they did do a round of work to remove most of the really dangerous stuff from constructors of things over the past few years in Java. So that got a little bit harder, but there's still stuff you can do if you can just trigger a constructor. But a lot of the common problems I'm seeing are literally just the default installer for a package that everybody uses turns on a listening port that runs code directly from the network with no password. And if that sounds like a stupid bug, it should. I think that the bugs are actually getting stupider as time goes on. And I think that is probably going to continue because the name of the game is going to be dealing with an increasing number of bugs in the source code that is being written for the economic reasons I was discussing earlier. And that's just going to be the way things go. And to get back to what I was talking about in the beginning, hackers on TV are smart, but hackers in real life don't have to be smart. You just have to find some mistake by a lazy developer. Pretty much, yeah. And the thing is they're not even lazy developers. No. Just I'm sure they mean well, but they just don't know any better. Yeah. And the thing is they all make the same mistakes. So once you see the mistake once, it's really fast to look for it again because our brains, the one thing they're really good at is pattern matching. So I have all these patterns for all these different programming languages for all these bugs I've seen in my head. So when I look at something, I just look for any of the bugs I've seen before. And as you do this over the years, you have more and more and more and more and more of those in your head. I mean, the other easy one, the obvious one, this is not just a Java bug, but this is every single programming language. If you want to find SQL injection, what you're looking for is string concatenation going into a SQL query. Because if they're using parameterized queries to build their SQL queries, there can be no SQL injection. But that also means that there probably will be no string concatenation at all. And so if you go into it thinking I'm looking for string concatenation going into a SQL query in whatever language you're in, that helps you find SQL injection really, really fast. And in some languages, and there are circumstances where you can do string concatenation to on the template itself to build up the parameterized template dynamically. If you're doing something really complicated with clauses, but you should never be just concatenating values into a query, right? So it's there's one edge case where if the guy really looks like he knows what he's doing, I'll string concatenation, whatever dynamic query, but there's probably a better way you could have done that, dude. Honestly, anyway, so I've done it. There's a thing in RadNet that does it. So I'm waiting. I'm just judging myself harshly right now, but in Ruby, if you're looking for SQL injection, everything in Ruby that goes to the database for the most part goes through active record. And you can actually build a one-line grep thing that will flag any SQL injection that happens inside any active record call as a potential SQL injection. Basically, if you see any the hash sign between the curly braces following any of the active record calls, select, update, all that. I built out this whole thing as a one-line regex grep thing, and then I could run that over any Ruby code, and it would have some false positives, but it would spit out every single instance of string concatenation that happened inside an active record expression. Well, anytime they included a variable, basically, and it would be this is what you need to look at, right? And I would run that. It would take 2 seconds, and then I would look through everything it spit out, and I'd be like, there's one, there's one, there's one, there's one, and then I would just go straight to how do I hit that SQL request with a web request, right? So you go backwards to how do I send this from the web? And then how do I, work out exactly what to put in the injection string so it does what I want? right?
Yep.
And then it's nothing magical. Like what makes it magic is once you kind of get into it, it doesn't even take that long. The first year I was doing this, I was starting to chain smaller bugs together. And that's the real magic, right? Like once you start finding piles and piles and piles of bugs, they're not all critical bugs. Like if you find a bug that just like runs your code, you send it code, it runs the code. That's great, but you're done, right? You found one bug, and you win. Okay. Well, then you gotta go back and find a different bug and like pretend you didn't find that bug or whatever. But you're gonna find a bunch of bugs that just give you some weird capability, but not full code execution or not full root, right? But they'll give you some little advantage here and there. And if you get a big pile of those together, you make a chain, where you have to go through multiple steps, but at the end of it, you win, right? And what I've noticed since I've been hacking into things since the early to mid 90s, what I've noticed is that in the beginning there were less steps to winning, and as time passes, there are more steps to winning. Sometimes with the log4j thing, that is like one step and you win, and that is what makes it absolutely terrible.
Yeah,
right. Like that is an embarrassment for our entire species. But I'm afraid it's probably just going to get worse from here, right? There's no, like, if you look at, Microsoft went several years without having any serious bugs, right? They were taking security really, really seriously for a while after like the Slammer thing was really embarrassing and all those worms, and then they were like, we're gonna treat software testing as a discipline. We're gonna take security really seriously, and then they actually had a pretty good reputation there for a while, right? Yeah. And that in the last year, 2 years, I think they've basically totally blown that. There have been so many tremendous Windows bugs that were just dumb oversights that we found out were open for years and years that people could have been exploiting this whole time. And they were just dumb things like, they left a copy of the registry hive that any user could access. That is a free privilege escalation for every user to system, and that was open for 2 years, and it was a regression. It was a bug they had fixed that then they broke, and no one noticed for 2 years. Like they broke it in some like rev of like Windows 8 or something, and then no one noticed for Windows 10 or Windows 11. This is what happened. So what happened is that in about 2015, 2016, they decided they were going to do away with software testing as a discipline. And they were going to rely on telemetry that they gathered from their users. Like they were going to live stream telemetry from the people using all their products over the internet. They were going to gather that in a big bucket, apply machine learning to it, and somehow that was going to be better than actually testing software, right? But I don't think that works very well for security bugs. Like that'll find crashes in user interfaces. Mm-hmm. That'll find. I mean, maybe that'll find performance issues, but honestly, that's really just going to find errors and crashes in your UI. That telemetry based testing is not going to find security problems, right? So, and they also had an internal discipline of doing internal pen tests and all that too. And I'm not really sure what happened there, but clearly some stuff has been slipping over the past couple of years because, they've had like remote exploits in, pre-authentication exploits in all of their flagship stuff that hasn't had bugs in like a decade, and not just that, like one thing after another, and I think there's blood in the water, for Windows is like a ton. There's blood in the water for Java, and these are still things that are just deployed everywhere. There isn't really a more secure, like there isn't an easy fix, right? There's like software systems written in Java. There's going to be Java running big chunks of the internet for decades. Mm-hmm. That just practically speaking, they're not going to rewrite this stuff. Like for example, big chunks of eBay are in Java, mm-hmm. right? How long is eBay going to exist as a thing?
I don't know.
Decades? Really? I don't know.
Probably.
But as long as eBay exists, they're probably not going to rewrite it into anything that's not Java. It would be an enormous amount. Yeah. So and the same deal with Windows, right? You've got some corporate network. You got 30,000 machines. They're running Windows. You've got a giant IT staff. They all know Windows. Like, on what timeline are you switching everything to Linux?
Yeah, it's not really feasible. No, it's just forget about it.
Well, so there's these huge forces of inertia that prevent systemic change from happening. So there's a huge resistance to systemic change that would make some of these classes of vulnerabilities go away or make them harder to introduce, right? So there's a ton of resistance to change. And in that environment, there is an ever-growing demand for labor. And that ever-growing demand is willing to accept an ever-reducing starting skill level for the people they hire. And they're trying to automate as much oversight as they can, because there are some companies that literally just cannot hire security engineers because there is no training program for it, really. Like, people have been trying to come up with training programs for it, but it's really hard. I've been with some of these workshops I've been doing, I've been thinking about this myself a little bit. I've been trying to train some hackers a little bit. You have to get them to hack something.
Yep.
And the first time somebody hacks something, they realize that wasn't hard. They realize everything I saw on TV has been a lie. Every smart hacker character that showed up and did something in 10 seconds or whatever, that's not at all how this goes, But if you're willing to sit and stare at something for a week or two, you can break it.
Yep.
Whatever it is, you can break it in less than 2 weeks, most likely. Like I said, your whole career doing this, you run into one or two things, maybe, if you're lucky, that were really, really hard, that really, really made you work for it. I've run into maybe half a dozen things, where the team was really, really tight, and I really had to work and chain together a whole bunch of things, and had to do some crazy stuff out of the box in order to win. But the vast majority of it is just, and the odds are that's fun for me, but your actual value as a professional hacker, as a security consultant, your actual value to your customers is that you are a yardstick. Okay. You are a hacker of a known quantity. You are going to work for a fixed period of time to try and hack into their thing. And they will learn from that whether or not their thing can survive that long against a hacker of that skill level, using a certain amount of resources, right? That is the actual measurement they're getting from you. Okay. So if I have to do something crazy that I'm the only one in the world who possibly could have done,
yep,
right? Although it's fun for me, it's educational for them. It's not actually that useful for them anyway. It's just those are the moments I live for, when I had to invent a completely new thing, right? Or if I had to break crypto to win, if they make me do something really, really hard to win, I respect that project. I will usually be very nice to them in the write-up. I'll be I did something completely unreasonable to win here, and this team should not be you shouldn't hold it against the team. I had to do something wild. But the vast majority of the time, you just roll in and you're making a list of all the problems you've seen before as quickly as you can,
Yep.
And as soon as that list gets a couple things on it, you can start finding bugs in stuff real easy. They are not rare. They are not hard to find. And it feels like you look at the Tavis Ormondys of the world, you're there's these really good people that are finding these crazy bugs and publishing all the time. But Tavis didn't find the log4j thing. Some dude playing Minecraft found that to cheat at Minecraft.
Right. Yeah.
That's what the world is now. People trying to cheat at a children's game.
Mm-hmm. Found major security problems.
Found a way to take over a nuclear plant, because there are nuclear plants that do run Java. Just saying. And I'm just everything that runs Java runs log4j for the most part. Except for 2 projects that use that other logging library, which now I'm sure everyone is I'm going to switch to something else, because it turns out log4j was just a complete goat rodeo, Yeah. And everyone has been using it for 20 years at least, and no one looked at it twice. No one thought, hey, Should we look inside that repo and see if it's a total goat rodeo? And this brings me to the current reason that all security work is futile. Dependency management is impossible. You cannot possibly read all of the source code that all of your repos are relying on. And if you don't update those libraries, you're going to get hacked. But if you do update those libraries, you're going to get hacked, like SolarWinds style. If you don't update, you're going to get hacked like Log4j. And if you do update, you're going to get hacked SolarWinds. There's no way you can automatically detect it happening in either case. And there's no way you can feasibly hire enough people to do the amount of work you would have to do to handle it manually. So every single company and person out there just needs to accept an almost impossible amount of supply chain risk.
Certainly.
And just live with it. You know, it's like, along with the possibility of horrible disease or dying in traffic or, with you, whatever else that can go wrong in life. It's just, death and taxes and dependency management.
Yeah, that's a really hard thing, dependency management, because like you're saying, you as a developer, you don't want to go over everything and write security hardenings and mitigation for all the dependencies. So to say.
It's not even that you don't want to, you cannot.
It's too much.
There are at a company with one security engineer, there will be thousands of dependencies. Easily. At a company with, at Microsoft, I don't know, they have a very large number of security engineers, but they have a much larger number of dependencies across all of the projects in that company because it's insanely large, right? I think that the problem of dependency management grows at a rate which is it grows at a much higher rate than you can hire your way out of. And I think that is one of the ways that thinking about computational complexity has kind of informed how I think about business. I'm not really a business person, so I tend to think about business in terms of computer science. So my whole understanding of the economics of the security industry is kind of based on big O notation, right? From computer science, where it's used to describe the efficiency of an algorithm. The points I'm making are somewhat supported by data, but
Yeah, I think actually we're running out of time right now. But is there anything you would like to say or touch more upon?
Yeah, well, so I've been talking at a pretty good clip. I'm wondering if you, what's your interest in Golang malware? What got you into this subject? What do you think? What do you think your listeners are interested in?
I think I know there's a lot of Golang developers out there, a lot of InfoSec people that use Golang because it's kind of the new kid on the block, so to say. And I'm personally really interested in what I've been playing around with is the AV detection. So there I get a lot of nice tools that I'm going to check out, because that's often a very hard thing to do, because like with Backdoor Factory, packers and ways to obfuscate the payloads, it's getting harder and harder. So it's you always got to keep staying up to date there. And like you said, Backdoor Factory was awesome, but then it got out of date. But hopefully it's being reborn.
Well, yeah. So in our rewrite, we wrote it to use BetterCap instead. So it's actually really pretty simple to rewrite. Once we had that library where we could parse, edit, and then regenerate binaries. Basically, all we did is we took BetterCap, which is a rewrite of BetterCap in Go. BetterCap supports not just ARP spoofing, but also DNS poisoning, also DHCP v6 man in the middling.
Oh, nice.
Yeah, and if anybody ever adds more capabilities to BetterCap, we'll just get that for free. But BetterCap also supports JavaScript-based scripting language they call Caplet script. And they had a Caplet script already called download autopone that would intercept the download when you were already man in the middling, and it would replace it entirely with a malicious binary. Okay. So all we did is we started with download autopwn, and we just hacked it a little bit. Instead of pulling a file off the file system and swapping it in, we just had it call out to our library. We took the file they were trying to download, passed it out to our library, injected the shellcode we wanted to inject, and then passed that on to the user, right?
Nice.
So all we had to do was write a little bit of BetterCap script, and that created the glue to this library we wrote to edit binaries, and then we were done. That was backdoor factory rewritten, you know? But it's all totally modular. Like we're using BetterCap to handle all of the man in the middle stuff, so that you can actually twiddle between, you can change what man in the middle thing you want to do, DNS or ARP, whatever. You can also, if anyone adds a new method to BetterCap for like a new protocol, we'll just automatically get support for that without even having to revisit our code.
How are you deploying BetterCap? Are you using it for pen testing? When you're in the middle on internal network, or have you used it in the testing?
So here's the thing, right? So I have done a lot of man in the middling professionally. One of the things that I actually use it for a lot is reverse engineering Android apps, but that's a kind of different style, right? So with the backdoor factory, I have two different scenarios that I wanted to use it for. One is the old scenario with the Wi-Fi pineapple. All right. So I actually did, like I said, because of the RatNet project, I learned how to cross-compile Go to MIPS32 soft float. I had some Wi-Fi pineapples. I actually wrote Wi-Fi pineapple packages to build BetterCap for the Wi-Fi pineapple, and also the backdoor factory. You can build them as OpenWRT packages that will run on the Wi-Fi pineapple. Those repos I actually added to the Wi-Fi pineapple module list, but they're also in the Binject GitHub, I think. And so that's one scenario. Of course, the problem you run into there is who is connecting to random Wi-Fi access points at this point and downloading anything unencrypted these days.
Yeah.
Not that many things. Turns out some embedded devices, but not that many actual people, right? Because most laptops and phones have been having this problem for a while. They are not connecting to anonymous Wi-Fi access points quite as easily as they used to, and a lot of browsers are forcing TLS for everything, right? So TLS stripping kind of doesn't work as well as it used to. Yada yada yada. What you can't just use a self-signed cert or something and just be like, look, there's going to be a pop-up, and maybe they'll just think it's Starbucks' fault and click through it, right? Mm-hmm. So you can rely on people just clicking through TLS warnings, but the browsers have been making that harder and harder. You've got to fish around and find the smaller and smaller pieces of text, right? They're trying to discourage people from doing that. The other scenario, and this is the one that I actually wanted it for, when I got into the data center pen testing, I actually got into kind of spoofing BGP.
Okay.
Oh, look it up. So you can spoof some routing protocols, and you can actually convince some machines that your physical hardware is really the IP address of a different machine they were talking to, right? You can route their request for a certain IP address that is not yours and you do not control to your machine by spoofing routing protocols in certain circumstances. There is a website called BGPmon, which I would recommend that you check out. So BGP is a global protocol that anybody can screw up. Basically, if you're a peer on the internet, BGP is not signed. It's not encrypted. Anybody can send a BGP message that'll get accepted.
Broadcast gateway protocol.
Oh, it's a freaking nightmare. So basically, there are countries that are man in the middling big chunks of each other's network every single day as an ongoing kind of cold cyber war. And since all BGP messages are published, you can literally watch. There are websites that show you animations of BGP hijacks happening all over the world in real time. And you can literally just watch like Korea and Japan hijack each other's IP space. And that actually does trigger a man in the middle like requests going to and every once in a while, like some Amazon IP gets hijacked, some Google IP gets hijacked. Like one of the main Google DNS things got hijacked once a few months ago. Like BGP is kind of a thing. So I was getting into BGP and I was like, hey, we'll spoof some BGP just inside the data center, like we'll redirect some internal addresses, to my machine. Yeah. And so they're all expecting to see a TLS cert that's signed by the CA, the internal CA. So then I was like, this is one of these multi-step things, right? Mm-hmm. Well, it's like, if I want them to connect to me and think that I'm, the other end, I need a real server cert. So what do you do if you need a real server cert? Well, you just pop one of those instances. Maybe it's running a passwordless JMX, and maybe you just log into that and pull a server cert off of that. And then maybe you're good to go, depending on what they're doing. Well, depending on what they're doing for internal PKI, depending on if they have it like locked down to each machine, which is really hard to do effectively, and especially it's like, if I have a real cert and I can arbitrarily lie about IP addresses and stuff like, so I was actually kind of looking at scenarios where, I was potentially looking at man-in-the-milling things inside the data center. And there was actually a third scenario, which is a little bit evil. This one is like, some people have brought this up to me and they've been fairly uncomfortable with it. But the other thing you could do is I have a fork of Backdoor Factory, which has added this functionality, but I have not merged it into the public repo yet, because this one's a little bit uncomfortable.
Okay.
But you can buy an Authenticode cert, for example, for like $300.
Okay. And
Windows binaries, for example, if they're signed, their odds are signed with Authenticode. And there are some signed package types that have known vulnerabilities where you can put code in there without having to re-sign anything. And if you kind of add those together, like you can make a situation where, say I popped the endpoint where it's entirely outside of the TLS tunnel entirely, right? Like say I've popped an instance that's behind your load balancer or whatever, that's actually where the files are. And I'm just like, let's just backdoor every file that anyone downloads from the server forever, right? I could like kind of make my own little proxy, when your web traffic's still unencrypted, and I can inject shellcode and everything that gets downloaded. And if you were Authenticode signing it, I could just buy an Authenticode cert, and I could put that in Backdoor Factory, and I can have it re-sign everything after it injects the shellcode. That's what the fork does that I haven't published yet, because it's a little bit like, it's kind of all fun and games until somebody. It was really trivial to make that modification to the Backdoor Factory that's in there, but I got a little bit wobbly about actually publishing it. I might put it out. I might put it out someday. A couple other people have implemented it also, and they have their own versions, and they also just kind of hit a wall. They're like, oh, we've published a lot of sort of malware components over the years, but this is sort of crossing a line, because what it runs into is like, what if someone in the government in Iran finds this repo,
Yeah.
It's like, it's literally
not good at all.
It's kind of working against my own, like, it's fun for me to have it, but I don't necessarily want anyone else to have it.
You don't want people to build bad things.
But it is, I think it is important, it is a way of proving zero trust, right? Because like, if you really set all your network up right and everything's really requiring crypto right, and your PKI is right, none of this should work, like, but it is surprisingly tricky to not screw up.
Yeah.
Well, that's a pretty good question. I do like man in the middling things. But did you have any other specific areas of interest?
No, I think we've gone through a lot of them.
Well, I think I don't know how long your podcast episodes usually go. On our podcast, we usually go until everybody starts to fall asleep. So
okay.
Some of those episodes have pushed like 3 hours.
Yeah, we have. I have one that's like a bit over 3 hours. I think this one's getting a bit long now, but I think we covered a lot of good content. And thank you so much for being on the podcast. How can our listeners stay up to date with what you're doing?
Yeah, well, thank you. It's been an absolute pleasure to be on, and I got to tell a lot of my stories. It was always a good time. So my name is Ben. I'm the host of a podcast myself called Hack the Planet. We have about 20 episodes up. We've had a slow year this year. I got slowed down by preparing for DEF CON mainly, and then this year had a lot of ups and downs. We do have another episode hopefully coming out very shortly, and we have another one in the can past that, so we are starting to rev up again. But you can find us. It's called Hack the Planet. You can actually, you can go, Alexa, play Hack the Planet podcast, and that actually works. Yeah, but we're also on I think like Spotify and Apple Music and all the things. But we have a website which is symbolcrash.com, SYMBOLCRASH, symbolcrash.com/podcast. We also have some blog posts up there. My GitHub repos are AWGH and Binject. And we do have a Twitter feed that I do not read and only post to via a bot. I tend to avoid all social media if at all possible. But on Twitter it's symbolcrash1. And we also have a YouTube channel. So all of our episodes we also render over a video loop for YouTube if you don't feel like dealing with the antiquated podcast technology. YouTube.com/symbolcrash also will take you to our episodes.
Awesome. We'll have that linked in the show notes.
Thanks.
Awesome. All right, Ben, thank you so much, and I hope to see you on the future episodes.
Thanks again. I'll see you later.